Guys, in this video I'm going to show you how to program your system to automatically restart your air handlers as well as any corresponding VAVs based upon a zone average. If a building gets too cold, that sort of thing, with a lot of older systems may not have this type of logic automatically built into them to where they will come up on an unoccupied set point. This series will show you how you can write that into your system. This particular building does not have an unoccupied restart system within its programming, and that's what we're going to be adding. This video will show you how some of the different logic blocks can relate to each other and show you just some of the basic steps of writing this type of programming. It's important to remember, even though this particular programming is to bring the building up on unoccupied heating, if the building gets too cold, it can just as easily be done to write the programming for unoccupied cooling. Some of you all in warmer climates than what we are here may be more interested in writing a program that will start on cooling. And basically what you will do there is simply reverse the comparator blocks that you will see us write in the LCT program. Okay guys, for this building we have two different NAEs, so we're going to be doing programming in both of them. The first thing that we're going to do is to drop down our programming folder, and we're going to actually add an additional folder in here to build the logic in. Now, it's a good idea to keep all of your work organized. That way, if you have to come back and do any troubleshooting later, it makes it much easier. So we're going to insert a folder. We're going to call it just something recognizable to what we are doing. I recommend you do this on all of the programming that you do. Like I say, it makes troubleshooting much easier. So now that we have that folder created, we also need to create a couple of additional blocks inside that folder. The first thing we're doing, again, go back to Insert Object, and what we're going to do now is actually put in an analog value. This is going to be the output from another object that we do. This is going to be where we do some temperature averaging. And we're going to call this, unoccupied or average zone temp, something easy to remember where we know what it's doing. And we give it a name, hit next, and this is more of our configuration screen. We're going to change this to degrees Fahrenheit. So, you can leave it blank, but I like to change this to where it is actually reflective of what it is. That way it's less confusing. Okay, we hit finish, and we're going to go ahead and add a trend onto this as well. That way we can kind of see what the building is doing, just exactly how cold it's getting, and make any adjustments from there. Just make it a little smoother, make it operate a little smoother. And we're just going to leave it, change of value. We have our trend. Now we need to create another object that is the signal select. This is the actual block that's going to be doing some of our calculations. So we go to Insert Object, and then we scroll down to Signal Select, and we hit Next. And we are just highlighting the folder of where it wants us to put it. We're going to give this a name as well. Once again, something that relates to what you're doing in the programming. And go on through. Now this is, let's resize this just a little bit. Our output section is down here. We can look at the average. We can also go the high as well as the low on this output. We just need to decide what we're doing for our particular situation. What we're doing here is we're going to be using the average. I click this little box. I then go down to find that particular analog value point that I created a moment ago. That is what we're going to be using for this point. That's what we want it to write all of the values into, the values that it calculates. Scroll down, I have that selected. Up here is list. This is where we're going to add in the areas that we're wanting it to look at. I'm going to resize this. We have to add these in one at a time. You can't do multiple at once. There's a total of 12, or a maximum of 12 objects that you can use in one of these. So I go to the first one. I scroll down to my trunk inside my system. I find the particular VAV set that I want, and I recommend on something like this, depending on how your building is, it works real well if you use rooms that are on exterior walls. That way, you know, those are the ones that are generally going to get the coldest. So I drop one of my rooms down, I grab the zone temp, I go back, I get my next block, and just repeating it over and over. I go to my next room, drop it down right there, select my zone temp, I hit OK, and it is now pulled that in as well. And basically what I do is I just keep doing that get all of my rooms in here that I want to add into this, and make it much easier. So I'm not going to bore you with many repeats of this. I'm going to go ahead and finish this, and you know, I'll pause the video, pause the recording real quick, and I'll go ahead and finish this, and then we will come back. Let me just grab one more here, and drop down our block, hit the zone temp, and now then, let's finish it. Now, we are finished with the adding all of our values in, so I hit OK. I'm then going to go down to the bottom here, and I'm just simply going to hit next, and we're just going to finish this block out. And hit finish, and now we have created the signal select. I'm not going to add any trends or anything like that, that's unnecessary. Hit OK, and we have now created a couple of the blocks. You notice that it did not appear in this window, but you can see that we are already getting our average output. You can see that that is currently the average for this group of rooms that we have selected. And that average is going to be very important in future steps. That's going to be our main control value. And now then, I'm just going to pull this folder over here. You can see it does not appear now, but if I drop this folder down, you can see that block that we created. So if I pull it over, there it is. That is the signal select object, as well as the analog value output. Now then, we have some additional logic that we've got to create. This is going to be done underneath the other NAE. And I do recommend to try to keep as much logic that you build underneath the particular device where those controllers are located. However, there are times, and this is one of those cases, where we do need to go through and build some logic inside another NAE that is in the same building. So it's kind of the same principles. You need to be cautious about that. If you have network issues, you can have problems here. Some of the logic that we have here, we're actually going to reuse. This is a minimum value block done in LCT that we are actually going to be reusing part of the values of for what we're doing. And instead of just blowing it out and rebuilding it, we're just going to reuse it for save time. There's other ways this can be done. It can be done a little simpler using the signal selects, but it's already there, so we'll just keep what we have and just incorporate it into what we're doing now. So our first step here, we're going to highlight the folder where we're going to create the next object, and we will need to create a couple of things here. We're going to add a folder, an object, and we're going to get a binary value. This is a simple on-off, that sort of thing, true, false, name it something that is related to what its function is. Can't stress that enough. And once we get that added in, get it named, we're simply going to go next. I'm going to change the state text here. There's a wide variety of what you can name the objects that you create. It's pretty customizable. What we're going to do on this one is just simply label it as unoccupied, occupied. It kind of relates to what we have the air handler set up as, so we will just continue that. We'll go on through here, finish this out, and we're done. We created a trend on that also. That way we can kind of tell how often the system comes up on that restart. Okay, now then, we will need to create some additional logic also. This is, multiple steps of building logic, and what we're going to do now is grab an analog value. This is going to be one of our set points. We will be able to adjust this set point to vary the restart. If the building gets below the average for those rooms, get below the set point, that's when we want the system to automatically restart to warm the area back up. You can do this as a static value in your programming, but something like this, we know that there's going to be some fluctuation in the set point, so we're going to go and make it a little easier to adjust. Once again, I'm going to select the units that I want, which is going to be degrees Fahrenheit. Very simple from the state text. And the relinquish default, I'm going to go ahead and put a value of 60 in there. I know that's going to change. I don't need any trends or anything on that, so we will leave that alone. That is the first of a couple of these values that we need to create in this folder. We're going to go in again and create another object, and we are going to grab another AV. This one is going to be a minimum temperature value. As you know, an average is just a calculation of a group of numbers. Inside, with what we're doing with this, it is possible that we can have a room that gets super cold, and the average will still be above the value we need for restart. So this set point here, and we're going to build it into our logic as well, is going to be the bottom number that we're going to let any of those rooms get to where it will bring that system back online. We don't want anything to get below this number. Same thing here. Grab the state text, change it to degrees Fahrenheit, that sort of thing. Hit next to go ahead and finish this out. This is kind of a little bit of added security for any of those areas, in the building. You don't want it to get super cold anywhere. Sprinkler systems, water lines, and that sort of thing. It's a good way to help your system function a little more efficiently. Now, the next thing that we're going to do is to create a control system, and this is where the magic happens. A little bit of LCT that I'm sure that some of you all who have watched some of my previous videos have seen me do. And this kind of gives you an idea of how some of these logic blocks can relate to one another. Now here is the bare bones blank LCT screen where we're going to do our programming. We're going to hit our edit button, and we are going to get a couple of the points. We're going to first thing grab that analog value that we created earlier, that average value, and pull it into our block. So I highlight it, I go down, drop down my attributes tab, and then I grab an input reference. We're going to, that's an input is to go out and get that value, bring it in. The next thing that we're going to do is we're going to grab the set points. We're also going to be grabbing outside air temp and that sort of thing. And we're going to be pulling those in here also. They are very important to have all of the, the values in. You've got to get all those in. An input reference is once again pulling something from the real world into this logic block. An output reference is telling something to go do something. So I'm now grabbing one of my set points, same principle, highlight it, drag it in. That's our, our average set point value, restart value. And then I'm going to do the same for the minimum. Now we need to do some comparison first, and we're going to go ahead and grab a comparator block, and it's going to be a less than or equal to here. If the average temperature is less than our set point, this block will go true. That's all it does, is just true false. And we're going to grab a constant as well to put in for our differential, a floating constant. So I just grab it, I drag it out here. I'm leaving that value at 1. That's all we need. And I drop that in there. This is our first comparator block. And once again, if the average temperature falls below the set point, the value will go true. The comparator will issue basically a true command. The LCT block that we looked at earlier actually has 2 outputs. It looks and issues out 2 minimum values. We're going to pull both of those into this LCT block and do a little more comparison. We're actually going to find the minimum of this, and you can see here we have an average, we have a minimum, that sort of thing right here in LCT. So we're going to grab the one that we need here, drag it out here to our work panel, and then make our connections. And this is going to do an additional calculation for us to save us the trouble of trying to set up another signal selector, that sort of thing. We're just going to pull them in here and use it this way. It's much simpler. Now we are going to grab our input reference. Here is our set point, our minimum temperature set point. So if any of the minimum temperatures in the building fall below this set point, our system will restart. And we're going to do the same thing here. It's another comparator block. If X is less than or equal to Y, we're going to make our connections here. We're going to go back to our floating constant here and tie it to our differential. And here we are. These 2 comparators are what will be used to restart the system. Now, the way that we're going to restart the system is, again, incorporating some previous control logic. We're going to bring in an OR gate here because we want it to restart if either of these 2 conditions are true. That is when we want the system to restart. And we pull that OR gate in, we make our connections, we will then go back to our point that we created. Remember earlier we created a binary value. That is something that we're going to have to pull into our screen as well. So we highlight it, we're going to grab an output reference this time and drag it onto our workspace. And this is going back out. This is, the logic does its calculations and then it outputs a value or set of values. And that's what an output reference does. We will make our connection then. We're going to add a timer because I want this to run for a minimum amount of time. I do not want it to start and then shut back off. And what I'm going to do is simply double click the timer. I am going to select off delay, and then I'm going to put a value of 3600 seconds in here. That's about a half hour. I do not want it to start and stop. I want it to run for a minimum of half an hour after these conditions are met before it will actually shut off. We have our connection made to the timer. Now the output of that timer, I am now connecting to my binary value. And I'm setting the priority at priority of 12. That is a troubleshooting thing that we do. That way it's kind of, we know that everything at that priority is coming from an LCT program somewhere. And when I press the save button, it gives me this. It says not all connections are made, and it's simply because I don't have the reset to that timer connected. I'm going to go through, I'm going to leave that open. It's no big deal. Works fine. Now that we have this set up, you can see our average and you can see our set point. I'm actually going to manipulate the set point, and you can see the reaction of our comparator block. You can see that it will switch to true and go through our timer, and it will turn that value on. And if I were to pull the panel over, which let's do a little bit of resizing here so you can see a little more about what's going on. And I am going to pull over into this view. I'm going to pull over the text that we see most commonly. And you can see here that my value is true. You can see the override. And this, our system is working fine. I'm going to go in here. I'm going to release that override. and you can see that the override is released. The output from my comparator has gone false. However, the timer is keeping that true, and it will remain true for a minimum half hour because of the way that timing block is set up. And that's very, very important. You don't want that system starting and stopping just instantly. And I'm going to do the same thing here on my minimum. I'm going to override it as well. And when I override it, you can see the state of the output of that logic block does the same thing. It goes true, and our timer would basically restart, and our output would remain on as well. So now I'm going to release that. It goes back false, but again, that timer will keep it on for a minimum half hour. So this is almost complete. There's still one more step that we need to do to tie this in to restart our system. And this goes again to using previously written logic. Our system is set up to where we can schedule a particular room, and then that schedule will then bring on the air handler as well as the common areas. We do that with an interlock. Interlocks are very useful. They're a very, very useful tool. And this one, as you will see, we are looking at all of the schedules. As when the screen pops up, you'll see those here in just a moment. It's rather large, so it does take just a little bit of a delay. And you can see here, these are all schedules within our system. If any of these schedules are occupied, our air handlers occupy, and it automatically occupies all of the VAVs for the common areas. So all I have to do now is simply hit the edit button and then add to this interlock that binary value that we have previously created. And once that goes true, it will be just like any of the schedules. It will then restart the air handler, and it will also bring on the common areas within the building. I'll scroll down and through my network. I will find the particular value, that binary value that we created a moment ago, and I highlight it. And once I highlight it, press the OK button, and then I will scroll down to where it populates in here, and you can see it's already, if this value equals occupied, then that's where it goes to the action tabs. And you can see that this is an OR gate inside this interlock, and that will restart the air handler as well as all of the common areas within the building. Once again, guys, if you need to set your system up where it will come up on unoccupied cooling, you will simply need to reverse those comparator blocks and inside the LCT programming, and then change your values to where you need them to be for your particular building. It is not much more difficult to add the logic where the system will do both. Restart on cooling as well as heating. It's very simple. Basically what you'll do inside the LCT programming is just write another set of values, a couple more comparator blocks, and then tie those through an additional OR gate, or just expand the number of inputs for that OR gate, and then let it go through the timer, let it go through the same logic that you've seen us create in this video. Guys, I hope this video is helpful to you. I would appreciate it if you would give it a thumbs up. Be sure to subscribe. Also, if you have any questions or comments, drop them down below.